Hey, hey. Thanks for being here. I'm really happy to be here. So let's talk about Kakarot today. Okay. Oh. Right. So today we're going to talk about the Kakarot's genesis after a quick intro on EVMs. We're going to talk about on our approach and why it's unseen before, and also the use cases. And I guess we could go back to the basics for a bit and talk about the EVM for a minute, because it even helps me to go back to it every once in a while. I'm sure everyone knows it already, but let's give it a quick intro. So the EVM is the Ethereum virtual machine. It's essentially a distributed state machine where all the smart contracts on Ethereum or Ethereum-like chains live. So it's where all your balances live, it's all where all your logic live, it's where the protocol guild lives, and essentially every execution client in the network has an EVM instance, and they use it to check that every transaction is valid. So I have 10 ETH, I don't, but what if I had? And I send 5 to the protocol guild, then the EVM is going to check my signature, is going to check that I have sufficient balance, and it's going to -5 my balance and +5 the protocol guild's balance. And in a decentralized network, every single execution client is going to run that transaction. So it's inefficient, but it's the best way we found to eventually have a common truth that no one controls. So why zkEVM, right? We started from the EVM, so it's this distributed computer that you can deploy your logic onto. So why I add zkEVM, ZK. So quick reminder, but zero knowledge is the part of mathematical cryptography that aims at solving either or scalability and privacy. And so for today, we're going to talk mainly about scalability. So essentially, I run a transaction, I send my money to the protocol guild. I have to convince every node in the network that the transaction is valid. So how do they do it? Well, it's simple. They just take the current state, take my transaction, and run it. So thousands of nodes are executing the transaction. Essentially, we would want for a better system to verify this, and we found one. And if you've been here today and yesterday, many people touched onto it, but essentially, we can now run once a computation and derive a proof from it, and for the rest of the time, people can just verify the proof. So we're going from everyone has to run my transaction to I run my transaction once, do a proof, and then everyone verifies the proof. And what's really cool about zero-knowledge proofs, and in this case, validity proofs, so they're not privacy preserving in our case. What's really nice is that they're exponentially cheaper. And that's the whole gist around rollups, right? You have layer 1 Ethereum, maybe a transaction is $100 to gift to the protocol guild. And on a layer 2, maybe it's going to be 5 cents, probably 1 cent in the future. And maybe for fractal scaling, it's going to be even less. And we can come back to the history of Kakarot. And it started as a community project back in Lisbon, but we can go even back in the past and talk a bit about the Cairo VM and the CPU architecture of StarkNet. So Shar, nice. Shar, the co-inventor of Cairo, found something very fun. It's essentially Cairo and the Cairo VM. It's comparable to the EVM, but the Cairo VM lets you write programs that are provable. So maybe I should have explained, but initially when you write Solidity, if you're a dev or if you have just any app, the output of this app or like transaction that you run are not provable by design. And that's why we built zkEVMs to add the provability inside of it. And Cairo is one of the ways you can prove computation. And so he found that Cairo is a general purpose programming language that lets you write provable programs. So if you were to not write any program but actually write the EVM, you would get an EVM that is provable. So you could verify any transaction that goes through this EVM. And essentially, that's exactly the definition of a ZK-EVM. It's an EVM environment or runtime where every transaction can be verified and provable, which is some side of the same coin, right? So he hinted at it a year ago. He was like, oh, what if we build the EVM in Cairo? We should probably have a ZK-EVM, right? And then Abdel, who is part of the lead innovation team at Starkwork, kind of started this effort, bootstrapped it in StarkNet CC Lisbon, and that's where all the core team met. So I met Danilo, the co-founder, and we lived all together in this hacker house, and we coded. And since then, the family has been growing, and the project has been really taking off. And we right now have more than 50 unique contributors all, on our repos, and the core team is about 7 to 10 people. All right. So what's been done so far? We have 100% opcode equivalence. We have 8 out of 9 precompiled. So this is somewhat comparable to what Polygon zkEVM has, as already pointed out yesterday. We should have a public testnet by end of summer. Maybe I should have done the soon trademark meme, because now we're aligned. And we're exploring some cool use cases for a zkEVM. One is rollup as a service. So essentially, when you go up a layer, the way I think about it, in some sense, you could think you delay finality and you get cheaper fees and higher TPS for it. So on Ethereum mainnet, finality is approximately 15 minutes with the checkpoints of ETH 2.0. And on StarkNet, it's right now 4 hours, and you would probably go down as much as possible. But if you go up a layer again, so layer 3s, maybe some of you have heard of the OP stack, but here it's different. But you could essentially do layer 3s, and the way you would think about it is someone, maybe Ubisoft, I don't know, wants a platform to build video games, and they would want very, very cheap fees and maybe 5,000 or 50,000 TPS. So they go up a layer, and what happens is many transactions get executed at the layer 3, they get batched onto layer 2, and then these ones get batched onto layer 1, and so you see that there's kind of like this recursive, exponentially cheaper compute. So we could build that. Kakarot is essentially very modular. It's just an EVM written in Cairo. So one person pointed out rightfully that if you write an EVM in Cairo, it's almost as if you wrote an EVM in Golang, which is what Geth has done, apart from the peer-to-peer modules and the rest. But Kakarot is very modular in that no one in the team actually is a cryptographer, and it can sound bad, but it's actually good because we don't need to be. There is an abstraction layer that is the Cairo VM that allows us to represent every transaction as a system of polynomials and then generate proof from it. And thankfully, we delegate this knowledge to Starkware. But our work is from the EVM onward, so it's solving the network effect for Ethereum. And what's really cool about this modular design is that down the line, maybe in 5 years or 5 years-ish, depending on the Ethereum roadmap, we could even prove L1 blocks. I'm not going to get tricked this time. I pushed it once. If I push it twice, it's going to do twice, right? Okay, I'm doing it. All right, cool. So we can touch a bit about how Kakarot works, because I think maybe it's important. Right now, Kakarot works as an EVM runtime on top of StarkNet. So it's literally a smart contract. And it makes sense somehow, because an EVM is not a node or a client. An EVM is the runtime that is used by a network to run programs. So Geth, the most popular client for Ethereum, is the EVM, but then also peer-to-peer module, data storage, and many other things. And for us, we just built an EVM. So we deployed it on StarkNet to kind of piggyback on their prover system and the ecosystem of StarkNet. And I'll touch onto that later. But right now, what happens is someone will sign an EVM transaction with their MetaMask or EOA. So they'll send any transaction to an EVM network. So in our case, Kakarot. And we have an RPC node that will kind of transform this, or like wrap this transaction without altering it at all into the StarkNet format. And I guess it's very important not to alter it, but this is safeguarded by the signature mechanism. So if you were to alter the call data or any part that touches on the core part of the transaction would just not be valid. So we just add a couple of things, such as the StarkNet corresponding address of the person, and so on. So the transaction reaches StarkNet, and it reaches our smart contract that essentially will pull the EVM bytecode of their smart contract and execute it. So why is this somewhat important? It touches on the types of zkEVM. And essentially, when you build a ZK system, you have two ways, roughly, of allowing people to write Solidity or any EVM language, and then outputting validity proofs. You can have a system that is able to watch transactions of EVM and prove them, or you write Solidity, transpile it to a zero-knowledge provable language, and then run your system. So for example, ZK-Sync, you may be familiar with it, launch their zkEVM. What they do is you will write Solidity, they will transpile it to their own language, and then run that. So this is transpilation. In our case, it's not. It's interpretation at the runtime. So what can one do with Kakarot today? You can deploy your Solidity or EVM language code base on StarkNet L2 without any change. Though this is not in production yet, right? But you can. It works. You can interact with Kakarot using the usual EVM toolbox. I guess for context, this is somewhat innovative because StarkNet is not compatible with the EVM or the EVM toolbox. So what you get as a user and as a developer is the toolbox you're familiar with. So that can help for many teams. And then in the future, we aim to interop with the really cool innovations that StarkNet has and that Eli has touched on this morning, such as storage proofs or even native account abstraction. And then soon, we're allowed to dream, we could one-click deploy your zkEVM at the L3 level using Madara and Kakarot. So I guess we could touch also on a hot topic, which is you should probably not build a zkEVM. First of all, it's very hard, at least if you're going the cryptography route, which Scroll and Polygon zkEVM have undertaken. And essentially, you could say we don't need another zkEVM. The L2 space is quite congested, and why add one more? And then there's no business model, or as someone said, I don't think zkEVM is a good idea. And it might sound like a hater comment, but it makes sense. The EVM was not built for ZK, and as such, it's not very friendly to it. The example that people usually take is, for example, the current hash function on Ethereum, which is Ketchak, is very not ZK friendly. So if you were to build from scratch a zero-knowledge environment and let's say a zero-knowledge virtual machine, so without the E, a ZK-VM, which is what StarkNet has done, you probably just get rid of all the ZK unfriendly things of the EVM. So you would get rid of Ketchak and get Poseidon and so on and so forth. So why would you want to bring the EVM back to ZK and kind of try to fit a rectangle into a triangle-shaped hole? And I guess my answer to this is probably network effects. We see that many innovations are kind of built on top of each other and sequential, at least some part of it. And even today, I think, I don't have the numbers, but heuristically, I think when a new team is onboarded onto blockchain technologies and devs are starting, they most likely start by EVM. They start by Solidity bootcamps, they start by web dev, and so on. And so why build Kakarot and not just contribute to other zkEVMs? I think we add something really cool, and it's the first zkEVM that does it. It's a zkEVM that separates zero knowledge and EVM. And to be fair, this is good. Zero knowledge is really, really cool, and devs rightfully should interact with it. But to some extent, you probably want to abstract zero knowledge away from devs that do pure engineering and then let them do their logic. So what I mean by that is full stack is increasingly becoming harder. So at first you had backend, frontend, now you have backend, frontend, blockchain, and now you should also be a cryptographer. So it's backend, frontend, cryptography, blockchain, and so you should read cryptography for the real-world cryptography, introduction to cryptography, should be able to audit secrets. I think that's a lot. And in our case, we built a zkEVM but used a ZK VM as an intermediate presentation, and that allows us to fully separate our EVM to ZK. One really cool thing is that our code base is very small, and code that is not written will not bug. Second part is any optimization that is done on the Cairo VM, we benefit from it. And then lastly, and it's not to be underestimated, and you heard it during the protocol guild talk, it's essentially, there are many new innovations on the EVM. Object format, EOF, same thing, 4844. So many hard forks in the EVM are gonna, so the EVM is evolving with time. And what's really nice for Kakarot is that the code base is very flexible. It's very small, and essentially we write the EVM in a high-level language. So this allows us to really catch up really easily, compared to, say, someone who would have to rewrite circuits for specific changes of the EVM, and then re-audit them and so on. And then I think the most important thing, and we should touch on this, is it performant? Like, it works, okay. It's very small, it's very elegant, but is it competitive? And I think this is what will make the difference in 3 years. And my mental model of this is, there's many L2s, there's many zero-knowledge rollups, and there's lots of traction and so many cool positive externalities that creates kind of dust in the air, and it's hard to say. And then probably in 2-3 years, the dust will settle down, and we'll know like the 3 most performance proving systems and zero-knowledge rollups and toolboxes. And personally, I think the Cairo VM will be one of them, because Starkware has demonstrated for the last 2 years that in production it's very performant. Now, people who are building zkEVMs are taking the problem by saying, so zkEVMs that without the Cairo VM, they're saying, okay, we're building a zkEVM, so let's take every opcode that the virtual machine has and build a like circuitry for it, and then super like over-engineer, but in a good way, optimize this. And this probably would end up in a situation where Kakarot is under-optimized, right? Because people are optimizing for the EVM, and we're building on a general purpose ZK-EVM. What's nice is that the benchmarks we have show that the Cairo VM is an order of magnitude more performant than other proving systems. And then Kakarot is an overhead of it, so it will definitely hinder this performance. And my belief is that it will just kind of rebalance things where Kakarot should be on par with others. Definitely, that's a belief, and we'll need to come up with benchmarks. And I really appreciate the Scroll team for pushing apples to apples benchmarks in the space, because right now it's very hard to compare Linea, zkSync, Scroll, and all the zkEVMs because the benchmarks are not like super standard. But I think they will be in probably 6 months or so. I know people are working on it. I forgot the names, but thank you. And there's so much to build, so much to build. We have Regenesis coming up on StarkNet, which means we have to rewrite our code base. It sounds bad, but it's not so bad. We wrote it in 6 months, and we didn't know much. Now we know more, and it's gonna be faster. Then I touched on it, but benchmarking is very important. It's important as an ecosystem to know what is what, and right now we don't have it. I think no one has it in comparable ways. And then we'll need to optimize for sure, because the way I think about it is we'll benchmark, we'll see that we lack some performance compared to others at KVMs, but it's very promising, and then we'll go through an optimization cycle. And then deploy to mainnet, what that means is that we'll give choices to people coming to StarkNet and on layer 2s to decide. They can come to StarkNet and write the programs in Cairo if they don't want the overhead of the EVM. And if they want the layer of abstraction of the EVM, they come to us. But in the end, it's the same problem that we're solving with Starkware or StarkNet on any layer 2. It's how do we gain mass adoption? It's teams building cool apps, and essentially you want these apps to be fast, and you want them to be sub-cents or like per transaction or even less. So I think we're all on the same mission, which is adoption of crypto, decentralized interactions and cool composability, and all of this at the minimum price. And that's the mission we're on. So thank you.